4y squared minus 6x plus 16y minus 11 is equal to 0. And this is a conic section. We don't know if it's a circle, ellipse, or hyperbola, so we have to put it in standard form. So I'm going to collect the like terms. So I'm going to have x squared minus 6x, and then I'm going to collect the y's, which is going to give me plus 4y squared plus 16y. I'm going to take the 11 to the other side, which is going to give me a positive 11. Completing the square here, I'm going to get x minus 3 quantity squared, plus I need to factor out a 4 from both of these, which is going to give me y squared plus 4y. And then I got to take half of that and square it, and I add 4. Now, half of this is negative 3, and I added 9 here. And half of this is 2 squared, that's 4, but technically I added 16 because the 4 on the outside will turn that into 16. So total I have to add 9 plus 16. And this is a perfect square, so that's x minus 3 quantity squared. Now we made this into a perfect square. That's 4 times y plus 2 quantity squared. All that's equal to 36. Divide everything by 36. I'm going to get x minus 3 quantity squared over 36. And then this reduces here to y plus 2 quantity squared over 9. Is equal to 1. It's in standard form. Now I have a center. The center of this is 3 comma negative 2. The radius in the x direction is 6. The radius in the y direction happens to be 3. And then I have my focal length. To find the focal length, it's going to be square root of 36 minus 9, which is rad 27. So if we were to sketch the graph of this, first let's plot the center, x-axis, y-axis. Center is 3 comma negative 2, call this 3, call this negative 2, and that's my center. From there, I'm going to go 6 units to the right. Okay, that will be 9. And then I'm going to go 6 units to the left, and that will be at negative 3. And then, from the center, I'm going to go up 3 units. That will put me at positive 1. And then 3 units down. So let me erase that a little bit here. So 3 units down from negative 2 is going to put me at negative 5. So go over here, call that negative 5, and there it is. Okay, so I'm going to connect all my dots. Let's go back. So connect that dot, and there it is. So connect those dots. That's my ellipse. My focal points are always located on the major axis, which is the x-axis right now. So that means I'm going to have a sum point right here. Okay, and that point is, this is 3, so it'll be 3 plus rad 27 comma negative 2, and then I'll have a point here, and that point happens to be 3 minus rad 27 comma 2. Okay, so that is it for number 1. So let's go to number 3. So let me erase this. So number 3. Number 3, I have 9y squared minus 16x squared minus 18y minus 64x minus 199 is equal to 0. Okay, first thing I'm going to do is I'm going to clean it up, collect the like terms, and move the 199 over to the other side. So that is going to give me negative 16x squared minus 64y y x, and then I have a plus 9y squared minus 18y is equal to 199. Now, I'm going to factor out 16 from both of those, so negative 16 is what I'm factoring out, so negative 16, and then I have x squared, then I have a plus 4x, and then I'm going to factor out 9 from both of these. I have 9, so I have plus 9, I got y squared minus 2y is equal to 199. Take half of that, square it, which is going to give me 4, and of course negative 16 times 4 is going to give me negative 64, so I'm going to subtract 64 there. And then take half of that, square it, which will give me 1. 9 times 1 is going to give me 9. I'm going to add 9. Okay, so on the right side, it turns out to be 144. And then I have a negative 16 times x plus 2 quantity squared plus 9 times y minus 1 quantity squared. Divide everything by 144, put it in standard form. And that's going to give me negative x plus 2 quantity squared over 9. Then I have a plus y minus 1 quantity squared over 16 is equal to 1. Okay, now I know what my center is. My center here happens to be x is negative 2 and y is 1. And then the radius in the x direction is 3. And then the radius in the y direction is 4. And my focal length of this would be opposite of what I did in ellipse. Okay, and this will be 9 plus 16, which is right at 25, and that is equal to 5. Now, when I graph this hyperbola, let me erase some of this stuff right here. When I graph this hyperbola, I'm going to graph everything just like an ellipse, but I have to know which way the hyperbola opens, and that is based on whatever's negative. Since x has a negative in front of it, it's going to open right and left. Alright, so let's go ahead and graph this just like we would an ellipse, and we'll go from there. Okay, so that's my x-axis and the y-axis. X is negative 2, y is 1, and there's my first point. That's my center. Radius in the x direction is 3, so I'm going to go over here, call that 1, and that's there, and then go over here, and then call that negative 5, so that's going to give me those points. And then from the y direction, I'm going to go up 4, so from negative 2, from 1. So from 1, I'm going to go up 4, so that would be 5, and then I'm going to go down 5, okay, go down 4, so if I go down 4 from the center, then that's going to put me at negative 3. Okay, so what I'm going to do is, instead of connecting these dots, make an ellipse, I'm going to make a box out of it to help me graph my hyperbola. Okay, then I'm going to connect my diagonals, and these are known as my asymptotes. Since it opens in the x direction, that's my one of the vertices, so it's going to get closer and closer to the asymptote. And then this is the second vertex, closer without crossing the asymptote. My focal points are always located inside the hyperbola. Okay, and this point happens to be my focal length is 5. So I started with this is negative 2. So if I go 5 units right, it would be negative 2 plus 5, which is 3, comma 1. And then this point would be negative 2 minus 5, which is negative 7, comma 1. And that's it.